Motor protection relay SE-B1 and SE-E1. This used to avoid motor overheating. We are going to discuss how it works, how to test, and how to install.
Say I'm gonna work, I'll work till I what?
The SE-B1 motor protector is a motor protector relay with PTC temperature resistance sensor. Has been developed especially used in case with motor having a high starting load and high switching frequency. The motor protector SE-B1 type is a motor protector that sensing your motor temperature coil winding. When sense the temperature exceeded on an equivalent PTC resistance connected on your motor, the motor is automatically shut off. This is the SE-B1 type motor protector having a connection B1 and B2. When you connect the B1 and B2 wire bridge, you are able to operate the motor protector to reset himself when triggered when sensing the resistance about 4.5 kilo ohms, and it will close again the connection on terminal 11 and 12 when the resistance lowered by 2.5 kilo ohms. If the motor coil winding exceed with a PT resistance about 4.5 kilo ohms, the terminal connection 11 and 12 normally close contact will open to shut off the motor and protect the motor coil winding from burning. Here I have new motor protector having SE-B1 type, and I'm going to simulate it by following the wiring connection here and identify how much is the equivalent resistance with motor temperature from which the normally closed contact 11 and 12 from close change to open, and from open will change to close. Normally this SE-B1 type motor protector will change its state from normally closed to open when the resistance of your coil winding has a value of 4.5 kilo ohms, and it will automatically reset himself when the temperature of your motor become less, giving an equivalent resistance of 2.5 kilo ohms. So I put here two lamps. This is connected on normally open on my left, and another lamp is connected on a normally closed contact. So I'm going to plug it, and I just connected my potentiometer here on the orange color wire, so I can adjust this potentiometer from 0 to 109 ohms. We try to simulate it for demonstration purposes only, but since I don't have a potentiometer having 4.5 kilo ohms, I just want to illustrate on how this motor protector is activated. So I just plug the motor protector having a 230 volt supply, and I vary from 0 to 109 and from 109 to 0. Normally the light from left will be goes off, and the light on the right side will be goes on when the resistance which we are trying to supply on the PTC terminal having a 4.5 kilo ohms. Then the terminal 11 and 12 from which the light connected on the left side on a normally closed contact will switch on again if the resistance of the motor coil winding have about 2.5 kilo ohm less. For demo purposes only, I just connected and do a simulation like this. Yan, 0.0 ohms. Mapansin nyo, no? Nakailaw pa rin to. Sabihin, yung terminal 11 and 14 natin open dahil naka-off to. Tapos yung 11 and 12 naka-close kaya nakailaw ito. So ganun guys, the higher the resistance, the higher the heat generated, kasi resistance is directly proportional siya sa temperature. Kaya at certain level, no, kahit ito ay mag 109 ohms, yung contact ng 11 and 12 still naka-close. So sa ganyang condition, yung compressor ng aking provision dipper ay umaandar pa rin. certain kilo ohm value, mag-open yung 11 and 12. So kapag nag-open yung 11 and 12, mamatay yung ilaw ko. Ito naman yung ilaw na yung nasa kabila. Mamamatay yung aking compression compressor number 1. So ganun lang guys, thank you very much. So what I did now is I do put a potentiometer on terminal orange cable wire having 109 ohms on my PTC, and I connected the supply L and N with 230 volts, and I just removed a lockout connection on B1 and B2. Then I just connected the bulb on the left on a normally closed contact terminal 11 and 12, and other bulb on the right side on terminal 11 and 14, which is normally open. So having a resistance of 109, the 11 and 12 contact is closed, so I have light on the left side. Then I'm going to lower the resistance of my potentiometer from 109 to 0 ohms, and as you may notice here, from 109 ohms going to the 0 ohm value, the terminal number 11 and 12 is still in close connection, and 11 and 14 is in open connection. So I don't have lights on our right side, and I have light on the left side. This is how the motor protector relay is operated. Here, as you can see, I measure the terminal orange cable having 8.72 kilo ohms, and this 8.72 kilo ohms is connected in parallel with the PTC connected on my motor. The PTC resistance I measure here having 0.15 kilo ohm. So by connecting 8.2 kilo ohm with 0.10 kilo ohms PTC sensor on your motor, you may expect that the resistance will be lowered. So take note, this PTC having 0.15 kilo ohms which was connected on my motor. As a preview, this motor protector relay works when sensing a resistance of 4.5 kilo ohms. When the resistance says having a 4.5 kilo ohm, this motor protector relay will be able to switch off the motor and stop the motor from running. As you may see here, I have now the compressor which is made by Bitzer, and I put and connect and simulate this motor protector relay. I apply a 230 volts on terminal L and N, and we further verify if the normally closed contact on this relay remain open. Then we try to start the compressor by pressing the circuit breaker, and as verified, when the motor protector relay is open, the compressor will not able to start and remain disengaged. So it is very important to have this motor protector relay be connected in a normally closed contact. So I just switch off again the circuit breaker, and I do a simulation and measurement. From L and N, I have 240 volts, and I just put a bridge on B1 and B2 to be able the motor protector relay to do auto reset at least 2.5 kilo ohms. Then as you can see here, the terminal 11 and 12, even I have a 240 volt supply, it has 0.00 ohms, meaning it is normally closed contact, and 11 and 14 is a normally open contact, you see. And as you may take note, my orange cable wire is not yet connected on my PTC sensor on a compressor. So I'm going to switch off this one, and now I'm going to connect the orange color wire on the PTC resistance or resistor which was connected on my compressor. So we connected it, and again I'm going to put a power supply, and we check again. I have 230 volts. Okay, 240. Then I'm going to measure also again the terminal 11 and 12, and as I verified, I just take the continuity on 11 and 12, and as you notice here, the 11 and 12 is remain in normally close. See, and the terminal 11 and 14 having a normally open contact in here. So on this motor protector, we are connecting the black and white color wire on terminal 11 and 12. So I do a wiring connection like this, and as you may notice here, the black on 11, the white on 14, and then I put here bridge connection on B1 and B2, and I have a power supply, the color brown and blue cable having 240 volts. Then I'm going to simulate again it by going on the motor compressor starter by switching on the circuit breaker, and as you may notice, this is the compressor. This compressor, by the way, is a new one and new installed, so I need to put this motor protector relay before the compressor will run to operate it in a safe operation. So as I started and measured, we've got a 440 volt supply on my compressor number 2, and we are successfully operated this compressor. Now my repair provision is working well, and my chief engineer, Chinese one, is happy. Thank you. Please subscribe to my YouTube channel so that I can share a knowledge with you for aspiring engineers on engine control rooms, electricians, ETR or ETO. Thank you very much. God bless you all.